morning everyone. My topic is preparation of phosphazenes. First method is method for polyhalophosphazenes. First, phosphonitrile chlorides are prepared by heating a mixture of phosphorus pentachlorides with a small excess of ammonium chloride in chlorobenzene or tetrachloroethane solvent at 120 degree to 140 degree Celsius. In this mixture, a mixture of cyclic phosphonitrile chlorides with and a short linear chain phosphonitrile chlorides is obtained. The main products of the reaction cyclic dimer and the cyclic tetramers and some linear polymers. The mixture is separated by distilling of the solvent and treating the residue with a petroleum ether. Second is these compounds are also prepared by heating P3N5 and in a chlorine at 700 degrees Celsius. Third, trimer phosphonitrile chlorides can be prepared by heating S4N4 with SOCl2 in PCl3. So reaction of these preparation is given here. And fourth is phosphonitrile chlorides are prepared by ammonolysis of phosphorus pentachlorides 5PCl5 plus ammonia PnCl2 3 plus 9HCl. Bromophosphonitrile compounds can be prepared by heating phosphorus bromide with an ammonium bromide similar to chloro products. Reaction is here. Fifth is the phosphonitric fluorides can not be prepared from PCl5 and NH4F because the ammonium chloride acts as a fluorinating agent and gives the product NH4PF6, and these are prepared by the action of potassium fluorosulfate on halogen derivatives. The reaction is here. And sixth is the mixture chlorofluoropolymer is prepared by heating the trimer PnCl2 with PVF2. So second method for other polyphosphazenes. The other types of polyphosphazenes were obtained from trimer by a general scheme. According to this scheme, the trimer is prepared on an industrial scale by the reaction of PCl5 with NH4Cl in an organic solvent such as chlorobenzene or tetrachloroethane. The compound was carefully purified and protected from the moisture. The purified compound was heated in the molten state in a sealed vessel in the absence of moisture for several days at temperature between 200 to 250 degrees Celsius to induce ring opening and polymerization. This resulted in the ring opening of the cyclic compound. The resulting polydichlorophosphazines, when dissolved in a suitable solvent, behaves as a remarkable macromolecular reactant and leads to the interesting nucleophilic substitution reaction. The reaction of general scheme for the preparation of polyphosphazenes is this. The treatment with organic nucleophiles such as the sodium salts of alcohol or phenols or with the primary or secondary amines resulted in the replacement of chlorine atom by organic unit. These derivative polymers are stable and possesses a broad range of unusual, interesting and useful property. So, ammonolysis of polydichlorophosphazines take place readily to form polyaminophosphazenes by the above method. The method is here. Some common examples of polyaminophosphazenes are some common examples of are these. Okay? It may be noted that in a case of bulkier group, the rate of replacement of last 20% of the remaining chloride atom required drastic condition towards the end of reaction. Solutions of polydichlorophosphazines in benzene, toluene, tetrahydrofuran react rapidly and completely with sodium trifluoroxide to give the derivative polymers such as trifluoroethoxyphosphazine. Structure of trifluoroethoxyphosphazine is given here.